2-3. We are continuing with 2-3. Here are the notes. Okay, yesterday we learned that the remainder theorem basically said that if you have, after doing synthetic division, if you get a number other than 0, then that means it is what? The remainder. Yes? Do we all understand that? It is the remainder. Then we learned the factor theorem. If something is a factor, then the remainder must always be what? 0. We learned that yesterday as well. So that's a quick review. The next thing that we need to learn today is what we call the rational zeros test. The rational zeros test is basically, I give you this polynomial, and I want you to come up with a list of all the possible rational zeros that it can take on. What does the word rational mean? Rational. If I tell you that it's a rational number, what type of a number is that? It is a whole number. What else could it be? Rational numbers are P over Q's, which means they are a fraction. Fractions are half, which is 0.5, or a third, which is 0.33 repeating. Correct? Irrational numbers are numbers like the square root of 2 or pi. Do we all understand that? So rational numbers are all the numbers that your brain likes to do calculations at. Does that make sense? Okay? Nobody likes to do a calculation at a square root, do you? No, that's not very much fun. Nobody likes to do a square root at or an imaginary number, or likes to do pi as a calculation. Now, P is the factors of your constant, and Q are the factors of your leading coefficient. And I'm going to talk about that a little bit later. Descartes' rule of signs. Descartes' rule of signs is a nifty little process that tells you if I have a degree 4, how many zeros should I have? 4. Out of those 4 zeros, it tells me how many of those zeros are going to be positive numbers and how many of those zeros will be negative numbers. And then how many of them are left to be imaginary. Do we all understand that? Okay? So that's what Descartes' rule of signs does. So basically what you're doing is you're counting the number of sign changes for positive roots, and you're counting the number of sign changes at f at negative x for negative roots. Okay? And it's easier for me to show you than it is to explain it. So what we're going to understand is that I need you to always subtract 2. So after you count the sign changes, you're going to keep subtracting 2 until you get down to 0 or almost a negative number. So for example, if I counted 6 sign changes, I would have 6 or 4, subtract 2 again, or 2, subtract 2 again, or 0. So 6, 4, 2, or 0. If I had 5 sign changes, I would have 5, subtract 2 gives you 3, subtract 2 gives you 1. Can I subtract 2 from 1 and get negative 1? I can't count negative 1, can I? So I'd have 5, 3, or 1. All right? And we're going to do some of those because it's not going to make sense until I do them. And then the last one that I really want to talk about is right here. And this is your discriminant. B squared minus 4AC. The quadratic formula, orange poster over there by Jeb. Okay, do we see that orange poster? Okay. You kind of already know it. You won't need to memorize it. You literally already know it. You just don't realize you know it. Okay? Here's the thing. If I were to take the square root of, let's say, -6. Can I take the square root of -6? No. So what type of solutions would I have? So I would have 2 imaginary. Does that make sense? What about the square root of 9? So this would be plus or minus. So this gives you 2 rational. What about the square root of 17? Irrational. 2 irrational. And then what about the square root of 0? What's the square root of 0? 0, does it impact the problem then? No, so you have 1 double root. So basically what it's talking about is if I have something that is less than 0 underneath the radical, it's 2 imaginary roots. If I have a perfect square underneath the radical, I have 2 rational roots. If I have a number that is not a perfect square underneath the radical, but it's positive, then I have 2 irrational. And if I have 0 underneath the radical, then it's going to be 1 double root. And you guys already knew this, and you kind of learned this last year with the quadratic formula. So I don't cover that as much, but it just gives you a visual as to what type of solutions you will have. All right, that brings me to the next concept. This is exactly like tonight's homework. This is actually problem number 2. You ready? It says, complete the following for each below. Verify the given factors by performing synthetic division. Remainder will be 0. What is it asking you to do first off? Well, look at the problem. Very good. So my problem is f of x equals x to the 4th minus 4x cubed minus 15x squared plus 58x minus 40. How many zeros should I have? I should have 4 because it is degree 4. Would you agree? Then underneath of that, it gives me factors. Notice how the factors look. X minus 5 and x plus 4. Do we see that? They're not listed as zeros. They're listed as factors. Do we see that? Okay. Now it wants you to confirm that those 2 are factors by doing synthetic division. So what you need to do is you need to solve this for x. So what does x equal? And what does x equal here? So what you're going to do is synthetic division at those values. Yep. So number 1, I'm going to do synthetic division at 5. So am I missing any powers? 4, 3, 2, 1, 0. I'm not missing any powers. So I have a 1, a negative 4, a negative 15, a 58, and a negative 40. Now I'm going to do synthetic division. Drop the 1. 1 times 5 is? Add vertically. Multiply diagonally. Add vertically. Diagonally multiply. Add vertically. Multiply diagonally. What did we just prove? That it is a factor because the remainder is 0. As soon as I did synthetic division 1 time, what does it drop the degree of the polynomial down to? Degree 1, degree 3, because I was at degree 4. Do we understand that? Now, we need to prove that the next one is as well a factor. And the way we're going to do that is we're going to do synthetic division again, straight from where we left off, using negative 4 in the box. So we're going to go right to where we were before. Do we understand what I just wrote up there? So we're going to use the numbers we just came up with. So I drop down what? The 1. And what did we just prove again? That it is a factor. Now, I want you to go back up to the directions, and I want you to say, okay, did I answer part 1 of the question? Did I verify that they were zeros? I did. So that's done. Part 2, it says find the remaining factors. Okay, well, wait a minute, folks. This is a factor. So I need my factors that I'm going to come up with to look like the factors in my original problem. Can you understand that? So how do I do this problem? Part 2. What is the remaining polynomial? X squared. And that is going to equal 0. So what do I need to do to this thing? I need to factor into 2 binomials if at all possible. Okay? So how do I factor this? X and X, 1 and 2, negative, negative. So what are my remaining 2 factors? Those are the roots. Did you hear what I just asked? Your factors have to look like your factors from your original problem. So these are my factors. Do we see that? Yes or no? We good? Okay. So did I answer part 2? I did. What's part 3? Write the polynomial in its most factored form. So all you're going to do is attach every one of those 4 highlighted parentheses together as 1. So this is going to be x minus 5, x plus 4, x minus 1, and x minus 2. Meaning, if I were to FOIL those, would I get the original problem? Yes. Do we understand that? Okay. Then, part 4 says to list all of the zeros. So what are my zeros if I'm listing them? X equals 5, negative 4, 1, and 2. Did I list them? Yes. And then part 5 says to confirm your results by graphing the original function. So what you would do is graph it and then do menu, analyze graph, and choose 0 and do that how many times? 4 times to confirm that 5, negative 4, 1, and 2 were your zeros. Do we understand that? This is how you're going to do problems 1 through 4 on tonight's homework. Do we understand that? Yes or no? We good? Excellent. Okay. Now, what we learned earlier today is we talked about the rational zeros. And whenever I said rational, what did we say a rational number was? Any number expressed as a fraction, right? So the rational zero test goes ahead and gives us every possible zero that is a fraction for that particular polynomial. So the way you're going to do this is you're going to find what P is. P is your constant. What is my constant here? Constant. That is your constant. It is your number without the variable. It is 3. So what are all of my factors of 3? 1 plus or minus 1, and then plus or minus 3. Why am I putting plus or minus there? A double negative can create a positive. Do we all understand that? Once you put 1 plus or minus sign, it counts for the rest of them in the list. Do we all understand that? Okay. Now, I then need to find Q. Q is your leading coefficient. What is my leading coefficient? And what are the factors of 2? Plus minus 1 and 2, correct? Now, what you want to do is P divided by Q. And this is the biggest mistake that the majority of students make in this because they are never able to figure out how to be consistent and not forget any of the options. So this is what I tell them always to do. Circle the first number in the denominator. And you're going to take every number in the numerator and divide it by that number. So what is 1 divided by 1? What is 3 divided by 1? Then go ahead and cross that off and go to the next number. What is 1 divided by 2? And what is 3 divided by 2? So now I know that I've done all of them. Do we see that? Okay. Now the whole point of this is sometimes we need to figure out how many times a function crosses the x-axis, but oftentimes we don't know if we have it in the correct viewing window. Would you agree? So what you're able to do by looking at this list, I can tell you that the biggest possible zero that is rational that I'm going to have is the number 3. Would you agree? The smallest possible number that I'm going to have is going to be what? -3. Oh, right? So what you're going to do is highlight this, and then I want you to think of viewing window. So your viewing window, if you were to graph this function, in order to see all of the possible zeros, I would have to go 1 unit outside of the number 3 and -3 to give me what? -4, 4. Because if I put it to 3 and -3, then you know what's going to happen? I won't be able to tell if it crosses there because it's going to cut it off on my window. Do we see that? So if I go out 1 unit on both the left and the right, I'll be able to see if it crosses there or not. Okay, so that's P over Q. Next, Descartes' rule of signs. I need to know how many possible positive roots I'm going to have and how many possible negative roots I'm going to have. The viewing window tells you how far out you need to go. Sometimes there's a function that you don't know. Is it going to cross way out there in like 100, or is it going to cross at like just 20? And a lot of times you zoom out and zoom out and zoom out and zoom out and zoom out. You with me? Or you zoom in, zoom in, zoom in. By doing Descartes, or not Descartes, P over Q, I know that the smallest number is -3 and the largest possible root is +3. So if I go out 1 unit on both of them, I can see all of my potential roots. You with me? Okay. All right, Descartes. So I want to, after I have my viewing window, I want to know how many of those roots are supposed to be positive and how many are supposed to be negative. So I can start eliminating possibilities off of my list. Okay? So how do we do that? Well, to find the positive roots, you are going to count the number of sign changes. And your f of x. And whenever I say sign change, I mean from one coefficient to the next coefficient to the next coefficient, all the way down to the constant term. So I have a +2 going to a +3. Did I change over from positive to negative anytime there? No. +3 to -8. Did I have a sign change there? I did. So there's one sign change. I'm going from a -8 to a +3. Is there a sign change there? Yes, there is. So that's my number 2 sign change. Now, do you remember earlier I talked about the n-2? How you're going to subtract 2 each time until you get down to 0 or a negative number that you can't use, right? Okay, I highlighted it on the one page. N equals 2, that's the number of sign changes that we have. So I have to have at least 2 positive roots, or 2 take away 2 gives you 0 positive. So I'm going to have 2 or 0 positive roots. 2 or 0 positive roots. Now let's talk about negative. Negative roots says that you are going to count the sign changes in f at -x. Count the sign changes in f at -x. So what am I going to do? I'm going to replace x with -x. Do we understand that? Which is essentially what you just said. So I need to do f at -x. So that means it's going to be 2 times -x cubed plus 3 times -x squared minus 8 times -x plus 3. Now there is 100% a pattern here. If I take a negative times a negative times a negative, that's 3 negatives. What's the outcome going to be? Negative. So this +2 is going to turn into what? A -2x cubed. If I take a negative times a negative, that creates a positive. So does my +3 change? No. I have negative x times negative 8, and that gives me a positive 8x. Now my question to you is what's the pattern? And it has to do with powers. Which coefficients changed their sign? I'm sorry? The even powered or the odd powered? Odd powered changed their signs from +2 to -2. Even power stayed every time, the original signs. So whenever you're doing f at -x, the only signs that change are odd powered variables. Do we all understand that? Okay. So with that being said, how many sign changes do you have here? -2 to +3 is 1. Positive to positive is none. Positive to positive is none. So my n in this case is going to be what value? So I have to have at least one sign change. What this means is, if I were to go ahead and make a chart, I have positive, I have negative, I have imaginary, and I have our total number of roots. Do we see that? How many positive roots does it say I'm going to potentially have? I can have 2 or I can have 0 positive roots. Yes? According to my lovely little power, how many total roots should I have every time? I should have 3. So I come over here and I'm going to put 3 both times. Correct? Now, with that said, how many negative roots will I have? 1 both times. So if I have a grand total of 3, but of those 3 roots, 2 of them are positive and 1 of them is negative, how many does that need to be imaginary? None. If I have 0 positive and 1 negative, how many does that leave to be imaginary? Do you think that kind of helps you whenever you're looking at your graph and be like, oh, I have to have imaginary here? So I'm going to have only 1 root that I need to look for. Then I'm going to be forced to do the quadratic formula. Does that make sense? Okay, let's do this again. P over Q. What is P? Is it your constant or your leading coefficient? It is your constant, okay? So P is known as your constant, which in this case is going to be 4. So what are all the factors of 4? Very good. What is Q? That's your leading coefficient, which is going to be 3, and that's plus or minus 1 and 3. Would you agree? Okay, now I need to do P over Q. So that's plus or minus, circle the 1 on the bottom. What is 1 divided by 1? 2 divided by 1. 4 divided by 1. Okay, so that's done. Go to the next one. 1 over 3, 2 over 3, 4 over 3. Yes? Okay, then pick the largest number in there. That's a 4. What's your viewing window going to be? -5 to +5. Do we understand that? If I am in my viewing window from x being -5 to x being +5, I know that I have all the potential rational roots that it can be. Do we understand that? If it's not in that list, then that means it's irrational or it's imaginary. Do we understand that? Okay. Now let's count the number of sign changes. We want to know how many of those roots are positive and how many of those roots are what? Negative. So how do I go about that? I need to find my positive roots. So I'm going to go ahead and count my sign changes in the original function. +3 to -5 is 1 sign change. -5 to +6 is another sign change, and then +6 to -4 is my third sign change. Would you agree? So that means n is 3. So if n is 3, what am I going to do each time to n? I'm going to subtract what from it? 2 units, right? So I can have 3, or 3 take away 2 is 1. Can I go any lower than 1? I cannot. I have to have at least 3 or at least 1 positive root. Do we understand that? Okay, now let's do the negative roots. Negative roots, how do I do this? Okay, so as at -x, which powers change the sign of their coefficients? The odd exponents have their coefficients change. So does 3x cubed stay or change? Changes to -3x cubed. -5x squared, stay or change? I'm sorry? Stays, because it's squared. It's not an odd power. It's an even power, so it stays. Does 6x stay or change? It changes to -6x, and then you just drop down the constant. Okay, so now what am I going to do? Always. F at -x, if you're doing f at -x, the odd powers will always change their signs on constant. Even stays. Odd change, even stay. No matter what. That's why I didn't do the work. Yes? Because what's a double negative? So it doesn't impact the -5 at all, because whenever you square a negative number, it still is going to be positive. And this -5 was already negative previously. You get what I'm saying, Haley? Okay. All right, so do I have any sign changes there? No, so what's n going to be here? 0, so I'm going to have 0 positive. So now what do I need to do? I need to make a chart. Positive, negative, imaginary, and my total. How many roots should this thing have?